All right, common logarithms and natural logarithms. The base 10 logarithm is called the common logarithm and is written as log of x. And it's understood to be log base 10. I say this often in math. In math, we have to understand the understood. Log base e logarithm, which would be written as log base e, is called a natural logarithm, but we don't actually write log base e. Like this is how, and I will as I do math problems, I'll write it just so that I can reinforce that a log base e is called the natural log. And it's ln because this is Euler's number. Euler was French, and you guys are familiar with Romantic languages. It seems like a lot of things they say and do are somewhat backwards of how we do it here in America. But anyways, it's the natural log of x, ln, natural log. All right, what is the value of each logarithmic expression to the nearest 10,000th? I want to remind you about what these things are asking, by the way. This is saying, by the way, we have an under log, so we have understood 10. It says, what power of 10 is equal to 900? Okay, so, everybody should know that it's between 2 and 3. Because 2 squared is 100, 10 cubed is 1,000. So it's between 2 and 3. It does lie between those two numbers. If I was a guessing man, I'd say 2.6 something. But I don't have a clue. I don't feel like doing that math. Yeah, I was way off. It's 2.9542. All right. Dyslexia kicking in strong this morning. All right, B, the understood base, since it's a natural log, is an E, and this one's pretty easy. This one can be done without a calculator. It says, what power of E equals E? And the answer to that one is 1. I swear it is. But, for you nimwits, I don't need the second key. I need to hit ln, second ln to get E. I need to raise her to the first power. Ta-da! It's 1. The natural log of E is negative 1.87. So is what power of E is equal to negative 1.87? And what this is asking you is asking if an exponent can make a number negative. Like, is that doable? Like, can you think of an exponent that makes a number negative? And, you probably don't know. You probably don't care. So you're going to go to your calculator and you're going to type it because that's what you're going to do instead of thinking and using that God-given brain. And you'll be like, Milbrath, I don't know what this means. Because that's how you talk. It's error non-real answer. It's not a real answer because you can't do it. And this is just as good a time as any to introduce this because it applies later in the lesson. But for any logarithm with an argument, the domain is that the argument must be bigger than 0. And you'll get that when we get to graphing. It's bonus question on your mother function quiz, but this is what a logarithm looks like. All right. You'll see that it does not cross that line. So we can't do that. It's just simple does not exist. DNE. It's not within the domain. All right, what is the solution to each equation? Leave an exact form around to the nearest thousandth and around to the nearest thousandth. So we're going to do a little technique here. Hopefully you memorize this by now. You'll have to know it by tomorrow. A logarithm base B, argument A equal to sum E has an equivalent inverse of a base with an exponent equal to the argument of the logarithm. Now, do not be the kid who can't pick out a base or an exponent. They exist every year, and it baffles me how genetically your DNA can combine and create something that can't pick out an exponent. That sounds pretty cruel, but I wonder. I do wonder. But anyways, this is an exponent. This is a base. Bases have exponents, which means that this is my argument. I'm sorry for being mean. It's early in the morning, and I haven't toned down yet. And I'm really just trying to be funny. But we have a logarithm of base 10, and her argument is 25, and she would equal x minus 1. That's what she would equal, okay? Now we're going to add 1 to both sides, and we'll be done. We have a log, and by the way, 10s are understood, so I'm going to go ahead and not write that 10. And this is the exact form. That is the exact form of the answer. If I want to know what the decimal is, I go to my TI-84 and I push some buttons. Because I can do that because 10 is bigger, or sorry, 25 is definitely bigger than 0. So I log of 25, add 1, always go 4 decimal places, which is the 10,000th position. It's about 2.3979. All right, next one, we have an ln, and an ln has an understood base of e. So this is the other way around. Think about this notation over here. You have a base, an argument, and an exponent. So the base is e. She gets raised to the 4th power, and she would equal 2x plus 3. Subtract 3, e to the 4th minus 3 is twice x, and then divide everything by 2, and you are done. And there's the exact form. If you want to know what she is as a decimal, again, you go to your TI-84, and you push some buttons. Second ln will bring up e. What was that, to the 4th power? And then minus 3, I'm going to do it in 2 steps because I don't want to bring up the fraction function, and then divide it by 2. And we get about 25.7991. Moving forward with our lives, these are try-its, and I'm not going to do all of them in this video. I'll be right back. Although I guess I should do it. You know what you should do if you're at home, homebound, whatever, is you should pause this video and try and do the things yourself. I'm just disoriented. I'm tired this morning. My base is 10, my exponent is 2, and I would have to equal 3x minus 2. Because base, argument, exponent. Base, exponent, argument, or answer. 10 squared is 100. We're going to add 2. Now, I don't need to do too much at once, do I? That would be equal to 3x minus 2. We're going to add 2. That's going to give me 102 equal to 3x. And we're just going to divide by 3. And I don't care what 102 over 3 is. Just leave it. Now here we have the other direction. We have a base, an exponent, and an answer. So we're going to do log is bay. We have a logarithm, base e. Her argument would be 8, and she would equal x plus 2. Now remember, log base e is ln, natural log. So the natural log of 8, we're going to take away 2, is my x. Push buttons if you want to know what she is. Always isolate before converting. Always. So we're going to divide out this 4 first. That's going to give me a log base 2 of 3x plus 1 equal to 1. Base, argument, exponent. 2 to the first is 3x plus 1. 2 to the first is 2. 2 take away 1 is 1. 1 is 3x. X is a third. Easy peasy lemon squeezy. All right, use logarithms to solve problems. The seismic energy x in joules can be estimated based on the magnitude m of an earthquake by the formula x equals 10 raised to the 1.5 m plus 12. These earthquakes follow a logarithmic scale. What is the magnitude of an earthquake with a seismic energy of 4.2 times 10 to the 20th joules? So they're telling you that seismic energy is x. So that's going to go in place of this one. 4.2 times 10 to the 20th is 10 to the 1.5 m plus 12. Now, I know this looks funny, and this is one of those things that gets some kids. But this base is all by herself. So here's a base, here's an exponent, which means this is the argument. So I'm going to convert to a logarithm. A logarithm whose understood base is 10, and their argument is 4.2 times 10 to the 20th must equal 1.5 magnitudes plus 12. So I can just push buttons on this and see what this is, right? Log, I done forgot the number, 4.2 times 10 to the 20th. 20.6232 is 1.5 magnitudes plus 12. So we're going to take away the 12. We're going to get 7.3768. I feel like that's right. I'm wore out, but I'm going with it. And that equals 1.5 magnitudes. So the next move would be to take that number, and let's check myself. Minus 12. Yeah, I'm off. Boy, I'm off. That's a really, Jesus. What was I thinking? Like 21 or something? 19? That's bad. Bad teacher. Yeah, of course it's 8.6232. What is wrong with me? Anyways, next move is to divide by 1.5. And I get 5.75. All right, so I'm looking over the scale there. And it'd probably be rounded to 0.7 because, you know, when the media reports things, they're just going to round it down to make it simple on people to understand. But it's about 5.75, and they shouldn't do that because it's a logarithmic scale. And there's a big difference between a 5.7 and a 5.75. Big difference. So the magnitude is about 5.75. And I think the last thing in our notes here is write inverses, and then we'll be right back. All right, first step, swap x and y. Get the f out of it. Writing inverses, okay? We subtract 5, we divide by 4, and this is the inverse of f of x. And I kind of ran through that because I spent a lot of time on inverses with y'all. So I fully expected you to remember what I did. Now B says this. This is a domain restriction. Because remember, you got to take away part of the quadratic, right? You got to get rid of part of it. So you're only keeping the stuff greater than or equal to 0. So provided that x is greater than or equal to 0, you can actually write an inverse. So let every x become y and every y become an x. And it's got 1, 2, 3 moves to solve. The opposite of adding is subtracting. The opposite of multiplication is division. And the opposite of squaring is square rooting. So the square root of x minus 4 all over 2 is the inverse of, this one was g, not f, is the inverse of g of x. And now we're going to do it with logarithms. It's the same exact process. Every x becomes a y, every y becomes an x. Now, what we're going to do is we're going to isolate the log, and then we're going to use log is bay. So I need to divide by 4 to isolate the logarithm. X over 4 equals a log whose base is a quarter of y. Base, argument, exponent. 1/4 is my base. She is raised to the x over 4, and she equals y. And now that you resolve for y, she becomes the inverse of L of x over here. So that would be L to the negative first of x, the inverse of L of x. We're going to do the same thing on D. Even though she's an exponential, we're going to isolate the base. So after we do our swapping here, we'll go through the process of isolation. We'll add 2. We'll divide by 4. And now we'll convert to a log. And you have to convert to a log because that's how you solve for y. But just identify your pieces. Base. Bases have exponents, therefore all of this is my argument. So I have a log whose base is e. Her argument is x plus 2 over 4. And she equals y plus 3. Now on the next line, I'll talk about log base e being what she is. She's a natural log. We're going to have to take away 3, and that would perform the isolation. This was called h, so we would write the inverse of h of x, and we would be done. And I feel like that's in your notes. Oh, we got some new tries, but I'm not gonna do those in this video. I'm just out of time. The bell's about to ring and classes are about to start.